Hello and welcome to another episode of Nerd Talk. This is going to be the final installment of the Macronutrient series. So we started with carbohydrates, then we went into lipids, and now we're going to talk about protein. So obviously we're going to omit a lot of information, obviously because we want to make sure that most people can understand it. But most importantly, what we want to include is the stuff that leaves application. So like it's good to know sort of what things are, but what does it mean? How do we apply it? And things like that. Obviously an obligatory flex for the camera so people know that I lift. I do not have my glasses on today too, so hopefully you guys still understand this is still a nerd talk. I just don't have my glasses today because I have a PowerPoint in front of me. So not that I don't remember this stuff, but so I can have an organized train of thought, because if not, I am literally going to be bouncing from one thought to the next, and I am one of those people that needs to write things down. That way I'm, more organized in how I deliver this information. So, why did I say protein for last? It's a little bit complicated. There's a lot of things that go into protein metabolism, and everything else, but I'm gonna kind of piggyback a little bit off of what we talked about in carbohydrates, how, the role of protein, its digestion and everything else. So like with everything else, protein, you consume it, you start breaking it down, through mastication, and then it goes through the alimentary canal, goes into the stomach, and that's actually where protein digestion, a bulk of it, will start to begin, because pepsin, which is, released from, the crevices of the stomach, they start breaking down protein, and then they go into the small intestine, and then proteolytic enzymes are released, which will further break down proteins. And when they're broken down, and this is why we wanted to kind of start this way, they become peptides. So basically peptides are the, smallest unit of a protein. Like glucose and fructose are the smaller units of a carbohydrate, and how fatty acids are the smaller units of fat. Peptides are the smaller units of the protein. So we have three types of proteins. We have dipeptides, which are like two proteins, tripeptides, and polypeptides. Polypeptides are very long chains, and protein consists of four groups. There is a R side chain, a central hydrocarbon group, a nitrogen group, and a carboxyl group. Now the nitrogen group is very important because if we look at lipids and carbohydrates, they're very similar in the fact that they have carbon, hydrogen, and oxygen. And that's it. What makes protein distinct is it's the only one that actually has a nitrogen group, and it's the removal of nitrogen that makes protein's metabolism so unique to the other carbohydrates. So there's different types of amino acids. We have non-essential amino acids. So basically your body can synthesize these amino acids endogenously. So you do not need to consume them through your diet. Your body can create them on their own. And then we have essential amino acids. Now, going back to the lipid and carbohydrates, remembering that there are essential fatty acids, but there are not essential carbohydrates. Protein and lipids are unique because there are certain things that cannot be synthesized within the body, so we have to obtain it through the diet. And these are the essential amino acids, which I'll get into later on. And when all essential amino acids are present within the protein, it is considered a complete protein. All animal products are complete proteins. Whey protein, eggs, milk, chicken, like any animal-based product that has protein in it will be complete. Vegan-based and vegetarian-based proteins tend to not be complete protein, so what we're classified as incomplete protein. So you usually have to do some food combining to get the essential amino acids, so all of them, and there's 9 essential amino acids. So a good way to remember all of them, if you give a fuck, unless you're an exercise physiology student, you probably don't, just remember the acronym Private Tim Hall. So basically PVT, TIM, HLL. So we have histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. So, and of those essential amino acids, we have another subgroup called the branched chain amino acids. So if you're like a gym bro who likes to lift out, you definitely know what branched chain amino acids are. There's isoleucine, valine, and leucine. Leucine tends to be the most anabolic out of all the branched chain amino acids, out of all 3 of them. Why is it anabolic? It's because it's profound effect on mTOR and protein synthesis. So when we're talking about anabolism, we're talking about building things up. And the antithesis to that would be catabolism, where we're breaking things down. Neither of them are bad or good. It's all context dependent. But when we're talking about leucine and anabolism, what we're really talking about and trying to harness is the building of protein and tissue, more specifically myofibrillar tissue, to hypertrophy. Protein metabolism, obviously there's a nitrogen group removed, and this is through the process of deamination. This is so it can be used as an energy source, fat synthesis, and gluconeogenesis. I mean, basically it just has to be taken apart so it can fulfill various roles within the body. So how much protein you eat is really a healthy balance of what we call nitrogen balance. So, with your protein intake, you have nitrogen intake, and then you have nitrogen excretion. Or positive nitrogen balance and a negative nitrogen balance. And at the end of the day, if your goal is to optimize how much muscle you build, anabolism, and things along those lines, you want to make sure that you have a positive nitrogen balance. So things that basically create a negative nitrogen balance, obviously illnesses and things along those lines, but sweating, working out, all these other things are going to create more excretory pathways for your protein intake, exercise, and all those things. So a positive nitrogen balance basically comes in the form of just making sure that you're consuming enough protein throughout the day, which we'll talk about now. So there's been a lot of studies and there's a lot of debate. If you ask my physiology professor at University of Idaho, she thinks the recommendations for protein are stupid. So for an adult man and woman, the recommendation is 0.8 grams per kilogram of body weight, which really isn't that much. So that's roughly going to equate for, 100 kilogram person, 56 grams of protein a day, which really is not a lot of protein. These numbers tend to be very, very, conservative. Now we know that anywhere from 1 to 1.5 to 2 grams per kilogram of body weight seem to be more ideal, mainly for athletes, people who are trying to stave off any type of muscle loss due to dieting or hard training. Recovery is extremely important because, like I said, we're trying to maintain a nitrogen balance. So hard training, obviously, with sweating and muscle protein breakdown and things like that, obviously are going to, lead to that. And that's another thing to think about too as well. When it comes to hypertrophy, basically your net gain that you get from hypertrophy comes down to, the balance between your muscle protein breakdown and your muscle protein synthesis. So if you have a net positive of muscle protein synthesis, and I know this is kind of like an overly simplistic way to look at it, the net balance will be an increase in muscle growth. It sounds simple, but it's in application very hard to really kind of zero in on it, because at the end of the day, I mean, if you're training harder, you're doing all these things, you can't really pinpoint exactly where you fall on that spectrum. So that's why it's important to kind of protect yourself with an ideal way of training and an ideal or optimal protein intake. So what are some of the, I guess you can say, utility in consuming an adequate to optimal amount of protein? Well, number one, obviously, is going to be increased recoverability. The essential amino acids are very, very important in terms of a functional role towards growth and repair of tissues that have been damaged. And if you are not eating an adequate amount, like I said, it's a balance between muscle protein breakdown and muscle protein synthesis. So if you are literally, I guess you could say, starving yourself of an optimal amount of protein, you're probably going to be leaving a lot of money on the table in terms of how much you recover, because we need, basically an accretion of protein in order to, I guess you can say, get this process going in the right direction. Another important role is the fact that protein obviously has functional roles in the body, especially as an energy substrate, because, at the end of the day, if you're not consuming enough of carbohydrates or things like that, protein can actually be used to convert into carbohydrates or lipids within the body, which are a much more efficient substrate for energy and the production of ATP. However, I highly recommend that you get an adequate amount of protein, an adequate amount of carbs and fat, because we really want most of our protein, if not all, going towards like its functional role in repairing damaged tissues. Third, it supports the immune system. Proteins are extremely important for immune function and things like that, especially proteins like glutamine, glycine, and various other roles in their body. I mean, they're very functional in the sense that, you know, protein can do a lot of things. Protein can be used as enzymes, proteins can be hormones, proteins can be used to support the immune system and various other functions. So that's why it's important that we just kind of don't always look at it like we're building muscle. It's more like we're promoting health. I know there's a lot of people out there that, you know, are under the impression that like autophagy, and then you just do sort of these like semi-starvation type fasting protocols where you decrease protein to increase autophagy, which is kind of silly when you think about it, because at the end of the day, the positive you're going to get from consuming an adequate to optimal amount of protein is probably going to outweigh like whatever type of speculative autophagy, you know, type of results you'll probably get. And you're probably better off trying to optimize your longevity, focusing on other things like making sure that you're eating a balanced diet, make sure you're getting enough sleep, make sure you're training hard, but recovering from those hard workouts, you're managing your stress appropriately. And lastly, in terms of functional roles for protein, its ability to really stabilize your appetite. There's been numerous studies that show that when we're comparing all three macronutrients, lipids, carbohydrates, and fats, protein seems to be the most, I guess you can say, profound in being able to keep you satiated or full. So that feeling where you're like, I don't really want to eat, protein is the macronutrient that helps the most with that. This is another advantage when you're dieting. You may want to eat more protein than what is recommended in the RDA and things along those lines. This is obviously an opinion of mine more than anything else. I mean, I can't really pinpoint a study where I can support this, but from my own personal experience, I know that when I'm knee deep in a cut, when I'm getting ready for a show, I'll eat a lot more protein than what is recommended by, you know, the RDA. And the result really is like a really profound effect on my appetite. Obviously, carbohydrates would be second, lipids would be third, but, you know, in the grand scheme of things, protein is going to be the most satiating out of all of them. So that is my nerd talk for today. I know I said that protein was probably going to be a lot more confusing and everything else, but, you know, at the end of the day, I just, when I have the PowerPoint, everything's where it needs to be. I guess it's just straightforward. To kind of sum it up, you want to make sure that you are getting the adequate amount of protein. That can be anywhere from 0.8, 1, 1.5, even 2 grams per kilogram per pound of body weight. You want to make sure that you're eating complete proteins, where you get basically all 9 essential amino acids. The branched chain amino acids, more specifically leucine, has a very profound anabolic effect. However, if you're getting enough protein at the end of the day, it's kind of a wash. It's not something that I would really worry about too much. But if you feel safer eating branched chain amino acids or consuming them, I don't really see any issues with that. It has a lot of variety of functional roles in the body: growth and repair, support of the immune system, I mean, a ton of functional roles, and also stabilizing your appetite. So that is my talk for today. Simple and straightforward. Is there anything that you want me to talk about? Is there anything that you're kind of like have a hard time wrapping your head around? Feel free to jump in the comment section, you know, like and subscribe, and I will keep pumping these videos out. So that's my talk for today. Take care, obligatory flex, and have a good day.